Let us talk about classes. Classes enable you to tie together the data and the procedures that operate on the data. Here is how to create a very simple class representing a product that we may have in stock. The class is called product. It extends the basic object type of Python. And the init method is what enables you to create objects of type product. So to create essentially instances of this class. The init method will take self, which is the object itself, to which we can assign values. We can modify it and enrich it. And it takes three parameters: the name for the product, the price, which by default is 0, and the quantity that by default is also 0. This initializer doesn't do anything particular. It simply stores in the object itself the values of the name, price, and quantity. So it says self.name, that is the object name, is equal to name, self.price is equal to price, self.quantity is equal to quantity. So it simply stores the values that you use to create the product into the product itself, which is represented by self. So if we define these, we can create a list of products. You see I created 3 products with by passing values to this initializer. So I say pear with a certain price and quantity, apple and onion. And then I can, for example, print them. I can iterate over the list and say the price of p.name is p.price, and this works because I have defined the .name and .price attributes of a product, right? So this works, but is not incredibly interesting. This simply enables you to put data together. Okay, in this case, a product simply has an initializer and the attributes name, price, and quantity that are defined by the initializer. But what we want to do is also tie together methods with a class, with an object. So here is a more complete definition of a product in which we also define 3 methods. The methods wrapper will define how the product is printed, and we simply say, hello, I am a and I cost $, so you have of me. And I replace these 3 holes that I pronounced as by the name, price, and quantity of the product. We have an inflation method that simply multiplies the price by a factor. Okay, in case you want to just inflate the cost of everything you have, or the price of everything you have, you can do that. And finally, I have a value method that returns the product of price times quantity. Notice I use here a property decorator because I want to be able to say p.value instead of p.value open and close parentheses. Okay? So notice that when I define methods, when I call a method, I would say something like, let me run the code and then give you an example. Okay? So if I want to create a product, let me write the example here. If I say, for example, p is equal to product of pear and the price is equal to 2 and the quantity is equal to 3. If I do this, I can then say p dot inflation by 1.2. Okay, and then say print p dot price. Okay, and we should see that the price has increased from 2 to 2.4. So notice this, that when I say p dot inflation, this 1.2 is gonna be the parameter x, and the object itself on which I call the inflation method, so this p essentially, will be as self. Okay. So when you define a method, the first argument to the method is the object on which the method is called. In this case, p in this invocation. And the second argument, or the rest of the arguments, are the arguments of the method itself. Okay? So I can create a list of products just as before. Okay? I can print the value of all the products. You see, here I don't need open and close parentheses when I call the value method, because I defined it with the property decorator, which enables me to avoid having to open and close parentheses. Okay. We can define a function double the curved, which doubles the quantity of everything in the curved. Notice that I can directly access attributes of the objects, no? And so this simply works. I can double the value of everything in the curved and then print again what is inside, and this has doubled the cost of everything.